The first video for this section was an overview of how lateral load becomes point loads acting on lateral load resisting elements. Now let's talk about a process we can use to perform that analysis. There are 5 steps we follow to go from lateral load on a structure to point forces on the lateral load resisting elements. The first step is to calculate the total lateral load applied to the structure. If the structure is experiencing pressure due to loading like wind or soil, we integrate the pressure over the surface area to get the total force. If the structure is experiencing seismic loading, we probably already have the total force calculated. It is called the base shear. We then save the total number to use later. Step 2 is to distribute the lateral pressure to the diaphragm levels. Typically, the floor and roof diaphragms are the stiffest things supporting the facade, the exterior wall, so the load gathers at those diaphragms. We will cover how to calculate the resulting distributed load at each diaphragm in the next video. If we are analyzing the effect of seismic loading, we skip this step because the load is already distributed along each diaphragm. Step 3 is to identify the lateral load resisting elements in the direction of the loading. To resist force, the lateral element needs stiffness, and the lateral elements only have stiffness along their long dimension. We will cover that in more detail in video 1.6b. There will be lateral elements in at least 2 directions since wind and earthquake loading can come from any direction. However, we only consider one loading direction at a time, so only the elements that line up with the loading are considered. Step 4 is to convert the distributed loads at the diaphragm levels into point loads at the lateral elements. How much of that loading goes to each lateral element is based on how stiff the floor diaphragm is compared with the lateral elements. We cover that also in video 1.6b. This step results in the idealized point forces at the lateral load resisting elements. However, we are not done yet. Our final step, step 5, is to check our results. To do that, we total all the point forces and compare that total with our result from step 1. The 2 numbers must match. If they don't, we have made a mistake. Common mistakes include forgetting the exterior wall that extends past the last column line, and neglecting some or all of the pressure on the parapet wall, that is, the wall that extends above the roof. To be clear, if the 2 loads do match, it doesn't guarantee that we are error-free, but it does mean that we have avoided the most common errors.